Hello everyone. Through this video we are going to discuss some of the important questions from exercise 11.2, that is the second exercise in the chapter of three-dimensional geometry. So here goes the first question. Show that the three lines with direction cosines 12 by 13 minus 3 by 13 minus 4 by 13. This is actually this set is the set of direction cosines for the first line, say capital L1. Then these are the direction cosines of the second line, say capital L2, and these are the direction cosines of the third line, say capital L3. We are to show that these three lines are mutually perpendicular. Now we have to take three cases here, one for L1, L2, then the second case should be for lines capital L2 and L3, and the third case will be for L1 and L3. Now these direction cosines of the first line L1 can be taken to be, say, small l1, then small m1, then small n1, and that for the second line L2 can be taken to be small l2, small m2, then small n2. Similarly, for capital L3, line capital L3, the direction cosines can be taken to be small l3, then m3, then n3. Now after this we already know one formula, that is what? Suppose if we want to check whether the direction cosines, I mean whether these two lines L1 and L2 are perpendicular or not, then with the help of their corresponding direction cosines we can find out this value, L1 into L2 plus M1 into M2 plus N1 into N2. If this result becomes equal to 0, then we shall understand that L1 and L2 are perpendicular. So on this basis I am going to solve this question. Okay, three parts we have to assume here, three parts we shall be assuming in this case. So these three parts separately we shall be doing. Now coming to case 1, first we shall be writing, let the direction cosines of L1 be small l1, small m1, small n1. Then the direction cosines of L2 be small l2, m2, n2. Then the direction cosines of L3 will be small l3, small m3, small n3. Then after this, case 1, for capital L1 and capital L2, let us check. We get L1 L2 plus M1 M2 plus N1 N2. The results will be taken from this list. These will be this this first value, this one will be acting as L1, this one will be M1, this one will be N1, and the respective values I am going to put here. It is 12 by 13. So here I get 12 by 13 into 4 by 13. This is for L1 L2, plus after this we shall be writing 12 by 13, I'm sorry, it should be 3 minus 3 by 13. It should be minus 3 by 13, minus 3 by 13 into 12 by 13, plus here I get minus 4 by 13 into 3 by 13. After complete simplification, let's check what result we get. We get here 48 by 169 minus 36 by 169. Again here it is minus, so we shall be getting minus 12 by 169. So ultimately 48 minus 48 by 169, the result comes as 0. This will imply what? Since L1 L2 plus M1 M2 plus N1 here it is N2 is equal to 0, this will imply L1 is perpendicular to L2. In the same way, for if we consider the second case, if we consider case 2, coming to case 2 here, case 2, for L2 and L3 we get we shall have to write here L2 L3 plus M2 M3 plus N2 N3. Let us put the respective values now. It is 4 by 13 of course into 3 by 13. These are obtained from the question itself. Okay, in the question it is given. Then 12 by 13 into minus 4 by 13. Then after we shall be getting 3 by 13 into 12 by 13. So this is for the second case. We find here 12 by 169. It should be again minus. It is minus. So we shall be getting 48 by 169 plus 36 by 169. Same is the case here also. 48 minus 48 by 169. The result comes as 0 by 169. So the answer will be 0. So this implies what? L2 is perpendicular to L3. This is case 2. Then after coming to case 3. Case 3. Here in this case we shall consider for L3, line L3 and line L1, we get, what do we get? L3 L1 plus M3 M1 plus N3 N1. Let us put the respective values. 3 by 13 into 12 by 13, whole thing is closed, plus we shall be getting minus 4 by 13 into minus 3 by 13. Then after we shall be getting again 12 by 13 into minus 4 by 13. So after this we shall get 36 by 169 minus, not minus, it is plus. It will be 12 by 169. Then here I get 48 minus 48 by 169. So the result will be like 48 minus 48 by 169. So result will be 0 by 169. So what answer do I get here? This will imply that L3 is perpendicular to L1. So what conclusion can be drawn? Therefore all the three lines are mutually perpendicular to each other. So this is the solution of the first question here, and this is the way we can solve it. Coming to the second question. So here goes question number 2. In question number 2, what is asked? Show that the line through the points, we can write here 1 minus 1 2. Then after end 3 4 minus 2 is perpendicular to the line through the points. What are the points written here? 0 3 2 and 3 5 6. So here in this case, what is to be done? With the help of direction ratios we can get the answer. For both the lines two points lying on both the two lines are given. Means for the first line we find these 2 points, this one and this one. These 2 points are lying on the first line, and on the second line these 2 fixed points are there. So using these coordinates we can find out direction ratios of both the lines. If I consider the first line to be L1 and the second line to be L2, their direction ratios, for the first one the direction ratios could be A1, B1, C1, and for the second one this could be A2, B2, C2. Then for A1 means first direction ratio of the first line can be obtained in the formula, using the formula x coordinate of the second point minus the x coordinate of the first point. That means I can get here 3 minus 1, the result could be 2. Then here in this case it will be 4 minus 1, the result could be 5. And in this case the direction ratio will be minus 2 minus 2, the result could be minus 4. Then at the same time the direction ratios for this second line, what can we get? 3 minus 0, the result could be 3. Then for B2 it will be 5 minus 3, the result could be 2. Then for this one it will be 6 minus 2, answer will be 4. So these are the values we are getting. Now to check whether these points or whether these two lines are perpendicular or not, for that we can use this form: A1 A2 plus B1 B2 plus C1 C2 should be equal to 0. So while doing the sum we can write the direction ratios of the first line are, this is just for your understanding I have shown. The direction ratios of first line are: A1 is equal to, we can write here 3 minus 1 is equal to 2. Then B1 is equal to, we can write here 4 minus 1, the result could be 5. Then C1 is equal to, we can write here minus 2, it is minus 4. Then coming to the next part, the direction ratios of the second line are, what can we write? Here this could be A2 is equal to 3 minus 0, it is 3. Then B2 we can get here 5 minus 3, the result will be 2. Then next one C2 will be equal to 6 minus 2, this is 4. We find A1 A2 plus B1 B2 plus C1 C2. Let us check what result we get. It is 2 into 3 plus 5 into minus 4. Then after 5 into, it is 2, 5 into 2, this should come as 5 into 2. Then after plus, it should be minus 4 into 4. So after this what do I get? 6 plus 10 minus 16, the result will be 0. So this will imply what? This will imply that L1 is perpendicular to L2. The first line is perpendicular to second line. This implies the lines are perpendicular to each other. So this is the answer. Coming to the next question. Question number 3. What is said here? Show that the line through the points 4, 7, 8, then after 2, 3, 4 is parallel to the line through parallel to the line through the points we can get here the points to be -1, then -2, then 1, then after 1, 2, 5. We have to show that the line through the points means actually we find that these two are the points lying on the first line and these two are the points lying on the second line. The question is exactly similar to the previous question, but thing is what, in that question, in question number 2, we had to check perpendicularity, but here we have to check the parallelism. And for parallelism, with respect to the direction ratios, we can find that the value this way. A1 means the result should come as A1 by A2 should be equal to B1 by B2 is equal to C1 by C2. If this expression is satisfied, then we shall understand that the lines are parallel to each other. So coming to the solution part, first let us find out what are the direction ratios. The direction ratios for line, say we can write here first line. For the first line are, what can we write? Say A1 is equal to 2 minus 4, the result will be -2. Then B1 will be equal to 3 minus 7, the result will be -4. Then C1 is equal to 4 minus 8, the result will be -4. Then the direction ratios of the second line are, we get here A2 is equal to 1 minus -1, it is 2. Then B2 is equal to 2 minus -2, it is 4. Then C2 we get here 5 minus 1 is equal to 4. So after this we shall be checking these ratios whether verified or not. And now A1 by A2 is equal to, we shall be getting here -2 by 2, result will be -1. Then B1 by B2 we get the result to be -4 by 4, this is again -1. Then after this second ratio we are getting C1 by C2, it is -4 by 4. We are getting the result as -1 again. So we can write here, since A1 by A2 is equal to B1 by B2 is equal to C1 by C2, this will imply that the lines are parallel. So this is the answer of the third question. Then coming to question number 4. So in question number 4, what is given? Find the equation of the line which passes through the point 1, 2, 3 and is parallel to the vector 3i cap plus 2j cap minus 2k cap. So here in this case, first of all, it is given that the line passes through the point 1, 2, 3. The line passes through the point 1, 2, 3. So first of all, we shall try to find out what is the position vector of this point. So coming to the solution part, see this exercise, this three-dimensional geometry is entirely based on formula, and all the formula are listed in the chapter actually before every exercise. So on the basis of this formula, each and every sum we can find out, the answer could be found out. So here also the same thing, given the line passes through the line passes through 1, 2, 3. Therefore, position vector of the line how can we get? We can take as vector A, that is equal to, we can write here I cap plus 2j cap plus 3k cap. How to find out the position vector? That is already given in the chapter of vectors. So here is the position vector of the point through which the line passes, and also given that the line means this line which passes through this point is parallel to this second line. So the direction of the line the direction of the given line is along say this is vector B, that is equal to 3i cap plus 2j cap minus 2k cap. Now in this case, when we find any line passing through a fixed point, passing through a given point with position vector A bar, say position vector A, in that case and also the line is parallel to another given vector B, in that case the vector equation can be found out. The vector equation can be found out using this formula. Vector R is equal to vector A plus lambda vector B. So using this formula I shall be finding out the equation of the line in vector form. It is not mentioned in the question in what form we have to derive it, so we prefer to find out in vector form only. If you want to find out in Cartesian form, then also it can be done. So I shall be writing here, hence the given the equation of the given line is, what could be written? Vector R that is equal to vector A plus lambda vector B. This implies vector R is equal to I cap plus 2j cap plus 3k cap plus lambda within bracket 3i cap plus 2j cap minus 2k cap. So this is the required result here in vector notation. Here is question number 5. In question number 5, what is given? Find the equation of the line in vector and in Cartesian form that passes through the point with position vector 2i cap minus j cap plus 4k cap and is in the direction I cap plus 2j cap minus k cap. So here is the question. This question is also having similarity with the previous one. So here in this case, both vector equation and Cartesian equation we need to find out. Vector equation could be found exactly in the same way as we did in question number 4, and Cartesian equation is a new thing which is to be added here. So in the solution part, we have to write here, given position vector of the point, through which the line passes. We can write in what way? Vector, it is always denoted by vector A. So it is 2i cap minus j cap plus 4k cap. Also, the direction of the line is along, we can write here vector B is equal to, that is vector B, the second one will be considered as vector B, that is I cap plus 2j cap minus k cap. Therefore, we can write here, first case 1 we shall be writing vector equation of the line is vector R is equal to vector A plus lambda vector B. So we can write here vector R is equal to 2i cap minus j cap plus 4k cap plus again lambda. In place of vector B we can write I cap plus 2j cap minus k cap. So this is the required vector equation. Then coming to the Cartesian form. In Cartesian form what happens? Just we have to write see vector R is equal to vector A plus lambda vector B, and the respective things we are going to put here as we did means if position vector of this point 2 minus 1 4 could be vector A and this one, so R can also be, if we consider any arbitrary point x comma y comma z, say if we consider any arbitrary point say x comma y comma z, this its position vector can be written in the form, always taken in the form x I cap plus y j cap plus z k cap. That is what we are going to do next. Actually all these vectors we are going to remove taking only the vector notations. Okay, x I cap y j cap plus z k cap, that is equal to 2i cap minus j cap plus 4k cap plus lambda I cap plus 2j cap minus k cap can be written like this. Now we are going to do what? We are going to take I cap, j cap, k cap together. In what way? Let us see. X I cap y j cap plus z k cap, that is equal to, from this entire part what can we write? If I keep aside, means if I take away I cap together, all the I cap terms together, all the j cap terms together and all the k cap terms together, so we can write in this way 2 plus lambda I cap, it is 2 plus lambda I cap. Then after we can write here, or you can say lambda, let the unknown terms we can write first, we should write first, so it will be lambda plus 2. Okay, it is lambda plus 2. Similarly we can write here plus for j cap, it could be what? Twice lambda minus 1 j cap plus we can write here minus lambda plus 4 k cap. So this is the way we can separate I cap, j cap and k cap on the right hand side. After this we can compare both the sides like this, comparing the coefficients of I cap, j cap and k cap. What could be obtained? This way we can write x is equal to lambda plus 2, then after y is equal to twice lambda minus 1, then z is equal to minus lambda plus 4. After this what is obtained? After this we can write what? Keeping lambda alone in one side, what could be obtained? X minus 2, yes or no? Then after y, it should be lambda is equal to y plus 1 by 2, am I right? Then here it is lambda is equal to what could be written? 4 minus z. So this could further be written as if proportionality in the form of Cartesian equation, if we want to write it, we have to arrange the things in this way, like x minus 2 by 1, then lambda is equal to y plus 1 by 2. Here it is lambda is equal to z minus 4 by minus 1. Now for lambda we are getting three separate things in terms of x, y and z. Now these things if we combine, we shall be getting therefore the required Cartesian equation what could be written is x minus 2 by 1, that is equal to y plus 1 by 2, that is equal to z minus 4 by minus 1. So this is the required answer. I have shown you all the deductions through this question only, means deduction of a Cartesian equation. I have shown through this sum. You can proceed directly through formula also. These steps you can remove. So this is the answer of question number 5. Next, coming to question number 6. In question number 6, what is given? Find the Cartesian equations of the line which passes through the point minus 2, 4, then minus 5 and parallel to the given line, x plus 3 by 3, then y minus, that is equal to y minus 4 by 5, that is again equal to z plus 8 by 6. Now in this question is also something similar to previous one. So here the line to which the given line is parallel is given in Cartesian form. So what can we do here is, I shall be writing in this way: the given line passes through the point minus 2, 4, minus 5, and it is parallel to x plus 3 by 3, then after equal to y minus 4 by 5, that is equal to z plus 8 by 6. So in this case, what do we find? The lines are parallel. It is given that both the lines are parallel. This concept of parallelism is there. That means their direction ratios are to be proportional. As the lines are parallel, their direction ratios are proportional. So the direction ratios of the first line will also be as that of the second line. That means 3, 5 and 6 are actually the direction ratios of the second line. But since the condition of parallelism is there, these direction ratios will be acting as the direction ratios of the first line also. So on this basis, what can we write? We can write here, this thing you have to mention here. How can we write? As the lines are parallel, their direction ratios are proportional. Hence the direction ratios of the given line given line will also be 3, 5 and 6. Therefore, the Cartesian equation of the given line. So we have to use here which formula? The formula for Cartesian equations, yes or no? The formula for Cartesian equation of a given line, that is what here I am showing you. It will be x minus x1 by L, or you can say A, then y minus y1 by B, then z minus z1 by C. So using this, here in this case x1, y1 and z1, x1, y1, z1 will be replaced by these values, these points, 2, minus 2, 4 and minus 5, because this is the point through which the line is passing. Therefore, Cartesian equation of the given line will be what? X minus, within the bracket it is minus 2 divided by this direction ratio we need to write here, that is equal to y minus 4. Y minus 4, this is the second coordinate, I mean y coordinate of the given point. Then this is divided by 5, that is equal to z minus, we have to write within bracket minus 5 divided by 6. So ultimately our answer will be x plus 2 by 3, that is equal to y minus 4 by 5, that is equal to z plus 5 by 6. This is the required answer for question number 6. Then question number 7 is also of the same kind. This could be done in the same way. Then similarly, question number 8 could also be done. Question number 8 is also given in the same way. Next time proceeding to question number 9. Question number 9 and question number 8 are exactly similar questions. If you know how to solve question number 9, question number 8 you will be able to solve. So coming to the solution part here, what do we get? Find the vector and Cartesian equations of the line and that passes through the point 3, minus 2, minus 5 and 3, minus 2, 6. So here in this case, two things you need to know. The vector equations could be found using this formula. In such cases where 2 points are given on the same line, vector equation for this is vector r is equal to vector a plus lambda vector b minus vector a. Means here in this case vector a will be obtained from this one and position vector of this first point, and vector b is the position vector of the second point. Then after coming to Cartesian equations, Cartesian equation, for Cartesian equation the formula is x minus x1 divided by x2 minus x1, then y minus y1 divided by y2 minus y1, then z minus z1 divided by z2 minus z1. So using these two formula we can calculate everything. So here in this case, coming to the first part, we shall first consider the case of vector equations. So here what do we get? The position vector of the first point is vector small a, that is equal to 3 I cap minus 2 j cap minus 5 k cap. Then after, the position vector of the second point will be vector b is equal to, we can write 3 I cap minus 2 j cap plus 6 k cap. Now the vector equation can be written in what way? Therefore before that let us find out what is vector b minus vector a, then the things will be much easier for us. So here it is, vector b minus vector a is equal to 3 minus 3 I cap plus minus 2 plus 2 j cap Then after, what do I get? 6 plus 5 k cap, and the result will be 0 I cap plus 0 j cap plus 11 k cap. So this is the result. So the vector equation, the required vector equation is vector vector r is equal to vector a plus lambda vector b minus vector a. So let us put the respective values. Vector r is equal to, we can write here 3 I cap minus 2 j cap minus 5 k cap. This is one part, plus lambda, it will be 11 k cap only. After this, if we want, we can write like this: vector r is equal to 3 I cap minus 2 j cap, then after plus 11 lambda minus 5 k cap. So this is the way we can write down our answer, keeping I cap, j cap, k cap separate. Then after, coming to the Cartesian form. In Cartesian form, directly we can substitute the coordinates. Cartesian form. Given points are, these points are what? 3, minus 2, then minus 5, and next one is 3, minus 2, 6. So here in this case, we can consider this as consider this as x1, y1, z1, and here it is x2, y2, z2. So accordingly, we can write the required equation. The required equation is x minus 3 divided by x2 minus x1, that means 3 minus 3, that is equal to y minus 2, then after minus 2 plus 2, that is equal to z minus z1 will be what? Z minus 5, then after 6 plus 5. So ultimately our answer will come like this. This implies x minus 3 by 0, that is equal to y plus 2 by 0. Then after, we can write here z plus 5 by 11, and this is the required answer. Now coming to the next question. Next question is question number 10. So in question number 10, what do I have to do? Find the angle between the following pairs of lines. Find the angle between following pairs of lines. So in this question there are two parts. Two similar questions are given, Roman 1 and Roman 2. So I will be solving only one. On that basis, the second one can be done. So here the first one, what do I get? Vector r is equal to 2 I cap minus 5 j cap plus k cap plus lambda 3 I cap plus 2 j cap plus 6 k cap. Along with that, the other vector given is vector r is equal to, what do I get? 7 I cap minus 6 k cap, then after plus mu, we get here I cap plus 2 j cap plus 2 k cap. So we have to find out angle between these pairs of lines. So the formula for angle between these two pair of lines could be like this. The formula is this one. Yeah, I get here. Cos theta is equal to vector b1 dot vector b2 divided by modulus of vector b1 into modulus of vector b2. Using this formula we can get the angle. So here in this case, what is b1 and b2, that we have to find out. Now we already know that b1 and b2 is considered to be these parts. So here in this case, this part will be acting as b1 and this part will be acting as b2. So coming to the solution part, in the solution part we have to write, given lines are these only. Given lines are okay, once again I am writing vector r is equal to 2 I cap minus 5 j cap plus k cap plus lambda 3 I cap plus 2 j cap plus 6 k cap. Then after, the other one is 7 I cap minus 0, because j cap part is not here, so we have to write 0 j cap. Then after minus, it is minus here, minus 6k cap, minus 6k cap. Then after plus mu I cap plus 2 j cap plus 2 k cap. So from both these two things, what can we write here? b1 and b2. Here vector b1 is equal to 3 I cap plus 2 j cap plus 6 k cap. Then vector b2 is equal to I cap plus 2 j cap plus 2 k cap. So these are the two vectors. Now we shall be writing, let the angle between them, angle between the lines be theta 1, or we can write theta only, theta between the lines be theta. Therefore cos theta is equal to, what could be written, vector b1 dot vector b2. The formula I am writing, modulus of vector b1 into modulus of vector b2. So after this, what do I get? Implies cos theta is equal to 3 I cap, dot products and all are already there in the chapter of vector, 2 j cap plus 6 k cap dot I cap plus 2 j cap plus 2 k cap. Then after, while finding the modulus, means actually magnitude we have to find here, so it will be 9 plus 2 square, it is 4 for the first vector I am writing. Then after plus 36. Then after, for the second vector it will be 1 plus 4 plus 4. Then after, in the later part, it will be cos theta is equal to, dot product will give us the result 3 into 1, it is 3, plus 2 into 2, it is 4. Then after plus 6 into 2, it is 12. Then after, in this part the result will come as root 49. Here in this part it is 9. So it will be cos of theta is equal to 12 plus 7, it is of course 19, 7 into 3. So the result will be ultimately theta is equal to cos inverse of 19 by 21. So this is the required answer. So on this basis, Roman 2 can be solved. So coming to question number 11. In question number 11, what is given? Find the angle between the following pairs of lines. Here the same thing again. Question number 11. Find the angle between the following pairs of lines. Here also two questions are given, both are of the same kind. I shall be solving the first one. The second one can be done in the same way. The first one is x minus 2 by 2, then after y minus 1 by 5, then after z plus 3 by minus 3, and the other line is x plus 2 by minus 1, then y, this is equal to y minus 4 by 8, that is again equal to z minus 5 by 4. So this could be done in the same way as we did in the previous case. Taking help of the direction ratios, this could be found out. So here the required formula is, the formula to be used here is, if suppose we get two lines, x minus x1 by a1, then y minus y1 by b1, then z minus z1 by c1, and then suppose x minus x2 by a2, then after y minus y2 by b2, that is equal to z minus z2 by c2. In that case, the formula to be used here is cos of theta, that is equal to modulus of a1 a2 plus b1 b2 plus c1 c2. Whole thing is divided by a1 square plus b1 square plus c1 square under root sign again a2 square plus b2 square plus c2 square. So what are a1 b1 c1 a2 b2 c2? These are the things. Here it is a1 b1 c1, then a2 b2 c2. So using this rule we can solve this sum. So I'll proceed with the solution part using this formula. So coming to the solution part, the direction ratios of the first line are a1 is equal to 2, b1 is equal to 5, c1 is equal to minus 3. Then after, the direction ratios of the second line are a2 is equal to minus 1, b2 is equal to 8, then c2 is equal to 4. Therefore, after this we need to consider, let the angle between the lines be theta. Therefore, cos theta will be equal to, I am using this formula, a1 a2 b1 plus b1 b2 plus c1 c2 under root sign a1 square plus b1 square plus c1 square. Here it is a2 square plus b2 square plus c2 square. So let's put the values now. After putting the values, cos theta is equal to, what can be written here? In place of a1 we can write 2 into minus 1. Then after, b1 is 5 into 8, b2 is 8, then c1 we are getting as minus 3, then c2 is 4. Under root sign it will be 4 plus 25 plus 9. Again here I shall be getting 1 plus 64 plus 16. After this, cos of theta is equal to, I shall be getting minus 2 plus 40 minus 12. Then after, the result will be in the denominator part 25 plus 9, it is 34, it is 38. Then after, in this part 16 plus 64, the result is 80 plus 1, it is 81. Then after, we shall get what? cos theta is equal to 40 minus 12. The result is 28. Then minus 2, it is 26. Then root 38, from this part it is 9. So our answer will be, in this case, theta is equal to cos inverse 26 by 9 root 38. So this is the required answer. So in the same way, the second question could also be solved. Then after, coming to the next question, question number 12. In question number 12, what is given? This is 12. Find the values of phi. Find the values of p so that the lines 1 minus x by 3, that is equal to 7y minus 14 by 2p, then after z minus 3 by 2, and 7 minus 7x by 3p, then after y minus 5 by 1, then after 6 minus z by 5 are at right angles. So here in this case, what is the way that will give us the value, means the result that the lines are at 90 degree to each other? So we already got one concept that if the sum of the products of the direction ratios of two lines is equal to 0, then the lines are said to be perpendicular to each other. So here we already are getting the direction ratios, but these lines are to be arranged to the standard form. So in the solution part, we shall be writing the given lines are say this is line 1 minus x by 3, that is equal to 7y minus 14 by 2p, that is equal to z minus 3 by 2. How can it be written in proper way? So the way to write it in proper way is x should be brought first, x minus 1, then 3 in the denominator part. In the same way, y should be independent here, y minus 2 divided by, actually both numerator and denominator should be divided by 7 to make y independent of 7. So it is 2 by 7p in the denominator part, then only it will be balanced. Then after, here it is z minus 3 by 2, it is already in the standard form. The direction ratios of L1, the direction ratios of L1 are what? A1 is equal to minus 3, then B1 is equal to 2 by 7p, then C1 is equal to 2. Then coming to L2, now L2 is given to be 7 minus 7x divided by 3p, that is equal to y minus 5 by 1, 6 minus z by 5 here at the last. So here in this case, what do I get? X minus 1 by minus 3 by 7p. What did I do here? Both numerator and denominator is divided by minus 7, and ultimately I got this result. That is equal to y minus 5 by 1, that is equal to z minus 6 by minus 5. Therefore, the direction ratios of L2 are L2 is equal to minus 3 by 7p, then B2 is equal to 1, C2 is equal to minus 5. Now we already know that we have to find out the sum of the products of these direction ratios. Now we can write A1 A2 plus B1 B2 plus C1 C2. Let us check what results we get. For A1, actually we needed to put minus 3. That should be multiplied with A2. It is minus 3 by 7 p. After that, for b1 we were supposed to put 2 by 7 p. That is again multiplied with 1. Then after, from the first line, the last direction ratio was 2. That should be multiplied with this one, minus 5. So ultimately what result we got? 9 by 7 p plus 2p by 7. Then after, this is minus 10, but we already are given that the lines are perpendicular. Now L1 is perpendicular to L2, so we get this is to be equal to 0, so we can write this implies equal to 0, this implies this is equal to 0. P is to be evaluated here, so what shall I get here? This is 7, then 11p, that is equal to 10. So ultimately what shall we get? P is equal to 70 by 11, and this is the required answer. So this is the answer of question number 12. Now we have to show in question number 13, what we have to do, we have to show that the lines are perpendicular to each other. So in the same way this can be done, the direction ratios are to be found out. The direction ratio, sum of the direction, actually sum of the products of the direction ratios is to be found out, and that should be equated to 0, and that will give us our answer. Then coming to question number 14. So this is question number 14 here. In question number 14 here, we have to find out the shortest distance between the lines. The formula for shortest distance we already know. Find the shortest distance. The question is find the shortest distance between the lines. So these are the lines given. Vector r is equal to I cap plus 2j cap plus k cap plus lambda I cap minus j cap plus k cap, and vector r is equal to 2I cap minus j cap, sorry, this is minus k cap, this is minus k cap here, minus k cap. After that, plus mu, I get here 2I cap plus j cap plus 2 k cap. So we have to find out the shortest distance between the lines, and the formula for shortest distance is what? ST could be found out this way. This is equal to first modulus, then after vector b1 cross vector b2, then after dot vector a2 minus vector a1, then after divided by modulus of cross product of b1 and b2, vector b1 and b2. So for this, actually first of all we have to find out what is a1, what is a2, what is b1, what is b2. All of you know this, how to get. So from the given lines, what can we get? A1, vector a1 is equal to I cap 2j plus 2j cap plus k cap. Then a2 we shall be getting as 2I cap minus j cap minus k cap. Similarly, vector b1 is equal to I cap minus j cap plus k cap. Then vector b2 we shall get as 2I cap plus j cap plus 2 k cap. So after this, what we have to find out now, vector a2 minus vector a1 is equal to 2 minus 1 I cap plus minus 1 minus 2 j cap plus minus 1 minus 1 k cap. So for a2 minus a1 we shall be getting the result I cap minus 3j cap, I cap minus 3j cap minus 2 k cap. Similarly, for vector b1 cross vector b2, what could be obtained? I cap, j cap, k cap. Here it is 1 minus 1, then 1, then 2, 1, 2. So cross product can be evaluated in this way. I shall be getting here minus 2. For I cap it will be minus 2 minus 1 I cap. Then after for j cap, if reversely written, it is 2 minus 2 j cap. Then after for the last one, it will be 1 plus 2 k cap. So ultimately what shall I get? Minus 3 I cap plus 3 k cap. Minus 3 I cap plus 3 k cap. So these are the results I got here. Now coming to SD formula. Therefore shortest distance is equal to first modulus you have to put here. Then after vector b1 cross vector b2 dot vector a2 minus vector a1. Then after modulus of vector b1 cross vector b2. Now let us find out the values accordingly. This is the modulus. Then here I shall write minus 3 I cap plus 3 k cap dot I cap minus 3 j cap minus 2 k cap. Then after coming to the denominator part, in the denominator part what could be written? Minus 3 whole square plus 0 square actually, then after 3 square. So ultimately we shall be getting minus 3 then minus 6. After that in the denominator part we shall get 2 into 9. So here it is. In the numerator part we shall get minus 9 divided by 3 root 2. After cancellation it is 3. Then always it should be written in rationalized form. So and distance can never be negative. That is why ultimately it is positive quantity, but the denominator should be rationalized. So answer will be like this: 3 root 2 by 2. And this is the answer. So this is how the shortest distance could be found out. Similarly, the next number, question number 15, can also be done. Then question number 16 and 17 are on the basis of the questions which we have already done just now. So thank you all.